Hello, everyone. Welcome to another session of Code with a Friend. So, today we'll be continuing our discussions of references and borrowing. In our last session, we covered about ownership, how Rust manages memory, how movement of ownership happens, and you can also move and take back ownership, stuff like that. So, mostly the content that we have covered so far, they come till 4.2 of the Rustlang reference. Let's see how much we can cover today. So today what I'll try to do, I'll try to just use the main function that I had created at our very first session, actually the main file. Uh, I'll try to just use that for testing out the different kind of language features because it does not seem that we are fully using the cargo builds. Essentially, we are just having one file structure for each of those builds. If we just see, right? So at maybe at level 3. So I think all the folders that you see just contains only like one main.rs file. So it doesn't make sense to do that. So just I'll try to quickly recap some of the Rust features while we are starting today's session, and then probably we'll go into the slice type, whatever the. I think the camera is a bit tilted. Okay. So what I want to do here, it's a simple switch case kind of operation, and I want to take like input from the SDIO, and based on the input I want to execute one of the tests, and each of the tests will have the features. For example, if I have, let's say, test 01 println bang hello from test 0 underscore 1, and if I have another test, I don't know actually how to write tests in Rust. Maybe there is an easier way, but I'm just doing my C style brain to create something similar. stdin, so how do we typically read from Rust is standard input? I think I forgot that. Read from stdin Rust. So we have to do stdio. Right, something like this. So we have to create a use stdio, and mm, now we don't want to create like a buffer results from this string. Yeah, so in right, something like this. So read line. I guess this is the one. So if we have to read it into a string. We can't just directly say string new or stdin. It's just a reference, and then stdin dot read line. We have to make it mutable buffer, and will this run? Rust c main dot rs. There is a result that is not used. That's I think fine. Result here, read line. Something like this. I'm not doing this okay here. Okay, this question mark that I don't know what it's used for, but it seems like this is fine. it can handle that. After that, I can just say if buffer, can I do a string comparison like this? Then we'll do a, then we actually call test01 else if or else if, right? So this time could be like very wrong here. Let me just try to do that. Oh, it seems like it works. Let's just run it. So I'm expecting something. We enter it, but it's not actually is 1 exactly. So did not match. So it didn't match. What I think here is probably we need to do some processing. We need to trim it. So I think there are many ways. So trim string rust. So we want to trim like both s.trim. Buffer is mutable, right? So we can do buffer.trim, something like this. Will this work? Found a string reference. Okay. Try removing the method call. So this will work because this is actually changing the type of buffer altogether. So now buffer is string reference. Now actually it matches. So here after the trim, it is actually matching. Can we do it in one line? I remember in one of the files we actually did this, maybe in the guessing game itself, right? So guessing game we IO yesterday in, yeah, so I think this is the exact same pattern I want to use here. So IO yesterday in, let's cut it, so I don't need this, just for better readability, put it down here, read line and expect fail to read line, something like that. And that we can also specify something like a question mark. So yeah, so basically I like ignore the error. Okay, and then again we just do guess u32, and then we do a parse, so we match it to a number, which is um, can I do like a match buffer dot trim? Can I do, let's say, one kind of expression thing here? If I can do that, will be super powerful. I don't know, I mean, pattern ampersand is not covered. Okay, so the match value is of type ampersand string, and ensure that all possible cases are being handled by adding a match. Okay, yeah, this is actually very helpful. Something like this, then it should not complain. Okay, and if I just run it, then I say 1, I say it twice. So if I just do 2, then test 0, 2, I think that is perfectly fine. So this is not needed. Even this buffer is not needed. It's the question mark. Okay, so I think we have the setup here. Now everything is fine, even though I don't handle it here. Uh, yeah, it actually says it, but it's fine. I can potentially handle it, and it'll all depend on what are the exact thing that I want to execute, not the other things. Cool. So now I guess we don't need this slice and stuff. So it'll be like a big function. I want to revisit at least some of the features which we have explored in our past session, just as a recap. But let's do that at the end of this session, I mean, at the end of at least 4.3. Then after section 4, we will sort of recap whatever we have learned, and then from next session onwards, we'll start 5. And in the meantime, probably we can remove some of the other cargo builds and just put everything together in a single main file so that it's easier for us to figure out. So let's go to the slice type. So slices let you reference a contiguous sequence of elements in a collection rather than the whole collection. A slice is a kind of reference, so it does not have ownership. Cool. Let's take the string of words separated by spaces, return the first word it finds in this string. If the function doesn't find a space in the string, the whole string must be rewritten in one word. So the entire string should be returned. Let's work through it to understand the problem that slices will solve. So we have fn first word s string. Okay, the first word function has an ampersand string as param. We don't want ownership, so this is fine. But what should we return? We don't really. So yeah, this is I think a pattern. Like we can provide an ampersand string value if we don't want to move the ownership from the caller to callee. It can just be a reference, and the caller should still continue to have the ownership. The first word function has an ampersand string as a parameter. We don't want ownership, so this is fine, but what should we return? How? We don't really have a way to talk about the part of the string. However, we could return the index of the end of the word indicated by a space. Cool. So let's try to implement as we are reading the code here so we can understand what's happening. So we define a function. It returns usize. Let bytes be s _4 bytes. Now we do for item bytes iter enumerate if item equals return I, and this should be slen. So basically I have a reference to a string and then I'm calculating the bytes of that, and now every time I'm encountering a space byte I return I. So if I write a function to do that, like test 03, something like that, test 03 and it'll just call the first word with, let's say, hello world. Should work. Oops. Then what should I do? Should I just do an ampersand here? Will that work? No, so we have to allocate something, right? So let buffer be this, and we just pass the reference to the buffer. What about that? Should be fine. Expected struct string found ampersand reference. I think I should have like a, yeah, string from, that kind of thing. Okay, okay, yeah, yeah, got it. So if I have a string from hello world, then probably that's fine, at least in one. Okay, yeah, but I'm ignoring sort of the return type of first word. I can just do a println. What is it? It's like something like this. Will it work? Okay, yeah, 0_3. Only this should be fine. Okay. Cool. So that works, and so now we have let word is force word will get the value 5. S clear, so this empties the string, making it equal to empty. Word still has the value 5 there, but it's no more string. Makes sense. Program compiles without any errors and also do so after calling s.clear because word isn't connected to the state of s at all. Still contains the value 5. We could use. Yep, having to worry about the index in word. Getting out of the sync with data. Is there a problem managing this? This is even more. Okay, now we are tracking a starting and an ending index, and we have even more values that were calculated. Okay, so a string slice is a reference. So it's like that Python slice thing, and it looks like okay, hello is a reference to the portion of the string specified in the extra 0 to 5 bit. We create slices using a range within brackets by specifying starting index, ending index. Got it. So not creating a new string, just keeping a reference. Makes sense. Makes sense. Okay. But importantly, we have to specify this ampersand s. String slice range indicates that the string slice range indices must operate at a validity of 8 character boundaries. If you attempt to create a string slice in the middle of a multi-byte character, your program will exit with an error. For purposes of introducing string slices, we are assuming ASCII only in this section. A more thorough discussion of UTF-8 is if you are storing UTF-8 encoded text with strings. So with all the information in mind, let's rewrite first word. Okay, so instead of so we got a bytes and then once we have it, we'll just, okay, so I think all this just to explain this, right? So this should be near person str person s. Okay, makes sense. We get the index for the end of the word the same way we did in listing 47 by looking at the first occurrence of a space. When we find a space, we return a string slice using the start of the string and the index of the space. Now when we call first word, we get back a single value that is tied to the underlying data. Let me display. I didn't understand this byte.iter.enumerate. I think this is like sort of thrown around in advanced, but interesting. So in this case, if buffer is cleared, okay, should be mutable. Okay. What about, oh, just do like a reference here and then printing later. Mutable borrow occurs here, immutable borrow later used here, something like that, right? Okay, so recall from the borrowing rules that if we have an immutable reference to something, we cannot also take a mutable reference, because clear needs to truncate the string, it needs to get a mutable reference. Oh, okay, yeah. So this is like only one reference at a time. If you can take multiple immutable references, but you cannot take more than one mutable reference. And even if you have like one mutable reference, the other thing will just be gone. This is interesting. String literals as slices. So when we talked about string literals being stored inside the binary, now that we know about slices, we can probably understand the same literals, okay? The type of S here is ampersand str. It's a slice pointing to a specific point of the binary. This is also why string literals are immutable. Okay, knowing that you can take slices of literals and string values leads us to one more improvement on first word, that is the signature. Okay, a more experienced Justice would write the signature shown in 49 like this. Improving the first word function by using a string slice for the type of S parameter. If we have a string slice, we can pass that directly. If we have a string, we can pass a slice of the string or a reference to the string. This flexibility Oh, what happens if I include this panicked? Okay. Now we have a string slice. We can pass it directly. If we have a string, we can pass a slice to the string as a reference. This flexibility takes advantage of deref coercions. What is a deref coercion? A feature we will cover in implicit deref coercions with function and methods. So there is like a lot of pointing happening to the later sections. Okay. I think the lighting was a little off for the first part. Anyway, so defining a function to make a string slice instead of reference to the string makes our API general without losing any functionality. Okay, so let's just name it 4 by the chapter name, right? So then it's easier to sort of correlate. Well, we can have like this also. Um, just 4_3_2. So we are defining my string as string from hello world. First word name, okay, second let word be first word. Okay, now we have my string literal is hello world. First word works with slices of string literals, whether partial or whole. Now we have word, first word, my string literal. Okay, because string literals are string slices already, this works too. So at least the compilation checks. But we just need to print all these words and see if it's indeed working fine. Thanks to the compiler for actually suggesting what to do. I think this is like a great learning experience. all giving me fine and correct. Other slices, so string slices, as you might imagine, are specific to strings, but there's a more general slice type too. Consider the array. Um, oh, awesome. So we can do an array slicing also. 4, 3, underscore 3, 2, 3, 4, 5, and let me allow a slice A1 colon 3 and assert equals slice ampersand 2 3. Okay, so the concepts of ownership, borrowing, and slices ensure memory safety, and Rust programs that compile time. Rust language gives you control over memory usage in the same way as other systems programming language, but having the owner of data automatically clean up the data when the owner goes out of scope means you don't have to write and debug extra code to get this control. Ownership affects how lots of other parts of Rust work, so we will talk about these concepts further throughout the rest of the book. Look at grouping pieces data together. So I think before that, what I want to do is I want to have like a basic file management structure, like defining some functions into a separate file. So Rust including other files, yeah. How can I include module from other file? Yeah, something similar. I don't want to do it through cargo though. Mod hello, and public print hello. Interesting. So then tutorial. File not found for module. So should just do a Am I? Okay, okay, okay. So yeah, I cannot build that, but okay. And I do 4.3.1. Okay. So now I think this is perfectly fine and exactly what I wanted. So the separation is very clear. I can just test a section of a chapter. Each of the chapters will have their own REST file, and within that file, we will have a lot of those scenarios listed. I can just look at that, all the public functions that are exposed here. So those could be my APIs to test what I need to test there. Thank you. So I think thank you to Renato Zanin. Anyway, so I guess like we are almost half the way through, and what I want to do is basically just to do a quick recap of the whatever we have learned from chapter 1 to chapter 4 because it's a long way to learn the entire thing. Chapter 5 we will have structs, and then chapter 6 we will have enums and pattern matching. There's a ton of things that we need to understand here. So before that, just let's go do a quick recap. Um, I believe the first chapter is essentially about, yeah, installation, hello world. So this is, I think, fine. Any chapter will have that. This is about cargo. Okay, so yeah, we have, I guess, maybe a hello cargo project just for that. Um, from what we need is from this programming a guessing game. So the guessing game could be, I mean, let's just move this entire thing. What I'll do is I'll name this like a guessing game function because that'll essentially run it. So programming guessing game will touch upon various REST functionality. That's the intention of this. So let's move. Where am I here? Um, guessing game source main.rs to tutorial. Okay, so it's not there. Chapter 2.rs, and this is will become my public function. To guessing game, or even I don't need that. It's just one function here, and I can include mod ch2. If I just say 2, it will just run the guessing game function. Right? Let's just do it. And I also don't want the entire guessing game cargo. Right? So rest c tutorial main.rs. Okay. Oh yeah, this one. I guess, yeah, there could be this expect no there. I don't know. I don't know any error handling right now. Okay, so this is actually difficult to do that because it has certain other dependencies. Um, just so the cargo was managing all those dependencies. Can you not manage those dependencies outside of cargo? Um, Rust dependency without cargo. Is it at all possible, or they have just, yeah, no, I think that's okay. Yeah, the cargo is fine, but I want to do it manually. Probably it's not the right way, but I want to do it manually. Um, Random GitHub and move it to np then cargo.ml will not work. Or can I have, yeah, I mean, I think there are pros and cons. Probably, if you are using a more stable product, then dependency management makes sense. But at least there should be some way to work around that. What I can think of is maybe we can have a single cargo project for everything so that dependency management becomes easier. Um, since I have deleted that, I have to just get it from our, so the cargo.tuml, right? So essentially we have to just build this rand dependency. Shoot. Okay. Yeah, I think I could not figure it out, but maybe there should be a way of managing dependencies outside of cargo. Or you define a random function on your own, right? Like, why do I need to create a dependency just to get, but this kind of situation can arise later, potentially. We might want to use something through cargo. So let's say cargo new tutorial. It already exists. Tutorial underscore C. Okay. What at this level tutorial sort of contains this. Um, so what I'll do, I'll move the tutorial main.rs to tutorial underscore C source main.rs, and we'll also move tutorial star rs to here. Um, and once we go inside this tutorial C, now we can just add this dependency. Can I go to the tutorial underscore C and do a cargo check. Seems it's working. Actually, I can remove the tutorial directory and move. But will it rename? So cargo minus help. Can I rename? Remove the target directory. Remove dependencies. Run the benchmarks. Search registry for crates. Package and upload this registry. Cargo rename. Is there a way? Not so difficult to really run this code. Cargo new minus burn. Um, this is also weird, right? What's here in cargo? Okay, it's not too much, so it could potentially be renamed. Grep minus RL tutorial underscore C. It's there in cargo lock and cargo TOML, so automatically generated. So let's just move tutorial underscore C to tutorial. I think this cargo.toml. No, this is under variables. Cargo.toml needs to modify cargo check. Cargo lock now is updated, I hope. Yep. Okay, and when I do cargo run, what should be my option? Okay, so the guessing game now works. Please input your guess. 50, too small, 75, too small, 87, too small. What's between 94? Too big. Okay, 91, too small, 92, you win. Okay, so this is, I think, working fine. So we had to bundle everything into tutorial. Hello Cargo is fine, but we don't essentially need it. What are we having in Hello Cargo? So Hello Cargo is also gone. Next we need for variables. This part is done, so let's move to the chapter 3. So common programming concepts, variables, mutability, data types and functions. What do we have in variables? Just this. Okay. I guess like these scoping kind of thing should have been there as a separate function, so it could be tested out. Then just quickly create a module for chapter 2. So variables also doesn't have anything, so goodbye variables. Coming back to, I think, ownership. Probably ownership has a ton of things. I'll come to ownership a little later. Let's go to tutorial, then inside source. Just save it. So let's call this, it has to be a public function, right? So scoping or chapter 3, maybe, yeah, chapter 3 underscore scope, something like that. Just for simplicity, I'll just copy it over. In main, I have module chapter 3 now. 3 underscore scope will call chapter 3 underscore scope. Or just make it 3 underscore 1 for simplicity. Should it be test? Cargo check. Okay. Cargo run. 3 underscore scope. Okay. Cool, so I think that is fine. Then there is a bunch of thing about mutability, data types. Any good example are the data types. I think these are basic operations, that's why I didn't cover them. Tuples, yeah. So I think this is useful. So let's just have a public function on tuples. Just call it 3 underscore tuples test232. Huh. 3 underscore tuples 6.4. Fantastic. But I don't want these kind of things to happen, so let's just keep it like this. So our cargo runs are fine. Cool. Okay, yeah, so I think this is also fantastic. Months, this won't actually work. Why did the previous one didn't work? Because accessing an element, index out of bounds, another function, function parameter, labeled parameters. Okay. No, I think this parameter is fine. Expressions, statements, return values, commands, control flow, if expressions. let's just have one more test3 underscore 3. Sweet. Okay, so I think that is nested loop. Public function test 3 underscore 4. Um, oh, okay. Okay, so this is fine. This is, I think, for loop, which is also very important. Public function test 3 underscore 5. 3 for loop. Okay, so on the ownership section, I believe this file has a bunch of code which could be moved. So now we are here, right? So we have to go one level up and go to ownership. Even one level here. Ownership, source, main. Tutorial, source, chapter 4 underscore 1.rs. So now let's bundle all of them together and put them under here. Public function test. Actually, these should be before, so let me cut these guys out, put them before. So we'll organize the naming accordingly. Public function 4 underscore 1. Change is an internal function 4 underscore 2. Oh, actually it's fine then. Calculate length is internal. Public function this, takes ownership, makes copy, 4 underscore 3. Okay. Yeah, I think that says fantastic. So we can just where are we now? Okay, then we have this is moved to and move ch4 underscore 1. Now we have here as 4.1, 4.2, 4.3. Just reflect these here. Should be fine for now. Fantastic. So I think that's like it's much cleaner, and it allows us to move to a better structure starting from chapter 5. We are just at the 1 hour mark, and it's a good way to sort of end our session today. We sort of restructured our code, make it more modular so we can just call it from our main function, and also we can have a separate freedom within each chapter. So each chapter can have its own code. In that way, it's much easier. Probably I'll just do a get push of my local changes. There's a lot of deletion that happened, and I'll also do a cargo clean, and let's do it one more bit more. Add, reorganize code. Now I think it should be there in the Rust expression directory. Oh, is it? Did not be. Oh, okay. Now I think it should. Organize code. Should reflect now. Cool. It's much simpler now. Fantastic. Thanks for joining the session. See you in the next session. Goodbye.